So you've just seen a video which is what happens when a trauma is encoded in the brain. And what I'm going to show you is what happens with havening touch. So havening touch and also those bilateral eye movements. So the first thing is we're going to have the surface of the receiving neuron in the amygdala. And what we've got is havening touch and bilateral eye movements. And with havening, rather than gamma waves, as you saw before, those very high frequency brain waves, what we've got with havening is a much slower brainwave activity. We've got delta waves. And you saw before that previously we had gamma waves, very high frequency, 100 hertz, but with havening, delta waves, much lower frequency, much calmer. So we've got 0.5 to 4 hertz. So the result of havening, as you saw before, we had all those receptors coming to the surface of the neuron. But with havening, we've got those receptors being removed from the surface, broken down and recycled back into the cell. So they're not on the outside, they've now been broken down and they're in the cell itself. And we call this, rather than potentiation, we call this depotentiation. We say that the cell has been depotentiated. Now the result of that, you remember before that we had the outflow of fight, flight, defensive rage and freeze, but here we've got no unhelpful responses to that particular encoded memory. We've got a delinking from the stimulus and the emotional response. We've got some associated neurochemistry going on here. So the neurochemistry that's generated here is serotonin. You might have heard of serotonin. So we've got serotonin, we've got oxytocin, and we've got GABA. And some of you might know GABA stands for gamma amino butyric acid.